All right, so chemical reactions. Well, chemical reactions, process by which the atoms of one or more substances are rearranged to form different substances. You probably already know that. Looking at our examples here too, a couple different things happening. We have, you can see in this particular example, you have this change of electrons. That's actually called a redox reaction, which we'll get to later. But also down here, I like these examples showing you like the atomic structure or the particular model down to like the atom level, where you see oxygen here, you see methane down here, and they're going to combine. But before they can combine into new substances, they have to break apart. So in order, the beginning, the reactants, the bonds have to break, and they separate, and then over here, new bonds form to form the products over on the right-hand side. So in this particular instance, the methane and the oxygen, they break apart, their bonds break, and then the rearrangement comes around, and we end up getting water and carbon dioxide as our products. So evidence of chemical change. This is something you kind of have to remember from back, I think this was Unit 1 stuff, long time ago. But if there's a temperature change, like if you put things together and a reaction occurs that heats up or it cools down, it's endo or exothermic, that falls under that category. You take two things, dump them together, and it ends up resulting in a color change. Odor, gas bubbles, of course, that's telling us one of the products is a gas. And the solid appearing as the precipitate. So this one over here in the corner shows you both. That one shows you both the precipitate forming. You took the two clear solutions, put them together, the yellow powdery stuff starts to fall to the bottom. That's also a good one where you had two clear things and now you have this solid yellow bright stuff showing the color change as well. So while we're doing chemical reactions and a lot of stuff we would do in the lab here, and we'll have a virtual lab for those at home, those here can actually do some of them, where you're going to look for these evidence, these signs that a chemical change has occurred. All right. I know that you guys know probably how chemical equations look and how they're written, but just to make sure, for the example, you're going to see things with coefficients. You're going to see the chemical formulas there, okay, using their symbols and stuff. You have the ones on the left, which would be the reactants. The ones on the right of the arrow are going to be your products. The arrow, of course, yields or forms, produces. That's what that means. Also, you might see examples like this where it shows you the particular models, showing you that, that the dark, the black circles are carbons, the red ones are oxygens, and the white ones are hydrogens there. That's also the methane example, except for methane being that very basic alkane that we studied, the very first one-carbon alkane. When it combusts in oxygen, burns in oxygen, produces carbon dioxide and water. And as you can see, it has the coefficients for balancing, which we're going to get to later. But before we get to balancing, we're going to be looking at types of reactions. Okay, so this is where the notes begin. And in your little chart thingy, we're going to put the generic, and then we're going to put the example. And then we're going to put the generic, then we're going to put the example, and so forth. So here we're going to start with synthesis. The basic definition over here, two or more reactants make one product. So here is our generic. We have element A, element B here. Those are your reactants. They're going to come together to form compound AB. So these are going to be your product, your one product. Now, you might see some synthesis where you have like a compound plus an element coming together to make one product. Most occasions, it's either two elements or a compound and an element coming together to make one product. So this goes in the first row under the generic part. And then we will do the example underneath. This also example shows you the particulate models here, showing you element A, the white circle, element B, the black circle, they come together. And this part right here where they're connecting shows that they have formed a bond. So now it's a new substance. It is a compound. And yes, you might see questions where you have to recognize it based on the circles. Pay attention to the patterns in the circles and the different shapes. Sometimes they use squares and triangles and other shapes to represent the different things combining or reacting and changing. All right, now for the example. So this will go in the second row. We have sodium metal, which is a group 1 alkali metal. It's going to react with chlorine. Elemental chlorine, remember too, is one of those diatomic ones. We're going to have to remember our diatomics. The 7 diatomics, that's nitrogen, oxygen, fluorine, chlorine, bromine, iodine, and hydrogen. But we'll go back over those. So this is stuff where we have to remember some of these formulas. They're going to come together to make sodium chloride. Now, yes, this is not balanced. We're not really concerned about balancing right now, but these two substances are going to come together to make the one product. We're really just identifying types of reactions here. So sodium metal, chlorine gas comes together to make sodium chloride here. All right, so anybody watch Friends? Seen Friends? No Friends? Okay, so here we have lovely. Anybody know who this is from Friends? Ross. That's Ross. Very good. Okay. Yes, and oh, by the way, you can make fun of me and date me because I actually watched this show when it was on Thursday nights on must-see TV. So back in the 90s, I was watching this show when it was live. Anyways, so we have Ross and we have Rachel, and they come, together and now form a couple. That would be like synthesis here. So you want to look at it. You used to have dancing people, or two separate people, and then they come together and they're dancing. But same kind of idea. Two things coming together to make one thing. All right, now some examples here. And what you need to do for reaction types is be able to recognize the pattern. So let's look at number 1. Is number 1 a synthesis? So is it two things making one thing? So this would be a no. Yes, I put this in the no category. Instead, it looks like we have one thing breaking apart into two things, right? So that one does not fit the synthesis description. How about number 2? Does number 2 fit the synthesis description? Yes, okay. We do have two things coming together to make the one compound. Alrighty, now how about number 3? No, I would say no. 2, very good. This is a no. We have one thing, one element, we have one compound, we have a compound, and we have a separate element. So those ones didn't combine to form one product. How about number 4? That would be a no too. Once again, one thing breaking apart into two things. How about number 5? Also a no, very good. How about number 6? Yes, we have iron and sulfur coming together to make iron 2 sulfide. Very good. And last but not least, number 7 here. Yes, that's a no. Definitely breaking apart. All right, speaking of breaking apart, let's talk about breaking apart. Because that falls under decomposition. One reactant breaks down, breaks apart into new things. So let's look at the generic here. In this case, we're starting with AB. So this goes in that first row. And it's going to break apart into individual things. So it could be a compound that breaks apart into the individual elements. It could be a compound that breaks apart into a smaller compound with an element or something like that. So decomp here, let's take a look at the particulate model. This particular model, we have a compound that has 3 elements, 1, 2, 3 elements in it. It breaks apart into a smaller compound with just 2 and 3, and then 1 over here is an element by itself. So as you can see here, one thing breaks apart into multiple things. Now for the example. We start with sodium chloride, lovely table salt. We like this, we use it for lots of things. It's going to break apart into its individual elements, sodium metal and chlorine gas, like so. So one thing breaking apart. It's pretty much the opposite of synthesis. Synthesis, you have stuff coming together to make one product. Here you have one reactant breaking down into multiple things. Alrighty. Friends, fortunately, Rachel and Ross here, maybe they break up for a couple episodes or something, and now are no longer together. And that happens like multiple times throughout the whole series or whatever, but that's really not a spoiler alert. Most people know that. All right, looking here. Number 1, would you consider that one to be classified as decomposition? Yes, good. We do have the one thing breaking apart into the 2 things. How about number 2? No. What is number 2 though? Correct. Number 2 happens to be synthesis. It's the opposite. You have the 2 things coming together to make the one thing. How about number 3? Nope. Nope for number 3. Alrighty here. That one is also synthesis. It's the opposite. We have 2 things coming together to make the one thing. What about number 4? Yes, very good. This is carbonic acid breaking up into water and carbon dioxide. So the one compound breaking down into 2 separate compounds that are smaller. How about number 5? Very good, yes. Magnesium hydroxide breaking up into magnesium, metal, oxygen, and hydrogen gases. So that one's definitely decomp. How about number 6? That would be a no. Good. That one's also synthesis. And the last example up here. What do you say? Yes, very good. We have calcium hydroxide breaking up into calcium oxide and water. Very good examples of decomposition there for some of those. All right, single replacement. Okay, generic. Now, for this one, you're going to put the generic in the first row, and then you're going to skip the example, and then you're going to put the second generic in the third row. Okay? Because this first one here has to do with the anion switch. Okay, C is the anion. Okay, does everybody remember what an anion is? Anybody remember what an anion is?
She's married to the uncle ion.
The uncle ion? Mr. Duke says she's married to the uncle ion.
That was funny.
Uh-huh, okay, I like that. Good one. Nobody remembers what an anion is?
It's like negative, positive.
It is a negative something. It's a negative ion. Very good. Negatively charged ion. Very good. So, it's going to replace the anion in the compound. So, this goes in the first row. As you can see, B is considered the anion here because we always write the nonmetal second in the compound, and the nonmetals are going to be the anions. They're the ones that get the negative charges. So C is going to replace B here. Okay? So that's the one type where the anion switches, okay? The other type, so skip a row, don't fill in the example, skip a row. This goes in the third row. This is the example where the cation switches. And if the anion is the negatively charged ion, what would the cation be here? The positively charged anion. Very good. So in this particular case, the C is going to switch with the A. Okay, we're going to see that happen. Okay, so there's two options for single replacement. Also, I want to make note real quick. If you Google any of this stuff or look stuff up, you know, online in textbooks or anything, you might see it written as displacement. Single replacement, single displacement mean the same thing, by the way. I believe our SOLs for chemistry are written as doing replacement, but you might see it as displacement in other locations. So that's 1 in 3 of our rows, the generics there. Let's look at our example here. So it's showing and the other way to tell this too, I guess I should show the particulate model here. Let's erase that first. An element plus a compound gives you a compound plus an element. That's the type of pattern you should see for single replacement. Element plus compound gives you compound plus element. Or vice versa, like they can switch. All right, example, this goes in row 2. Row 2. So we have NaBr plus Cl2. In this particular case, this is going to be the anion one that switches. So we have the Br switching with the Cl, the nonmetal switching with the nonmetal. Okay? The nonmetal switching with the nonmetal. And typically, the anions are going to be these nonmetals, all right? So we end up getting NaCl and then Br2. Remember, bromine is also one of those diatomic ones. So this goes in row 2. This is the example for the anion one. For the cation one, it's usually a metal replaces a metal because those are always positively charged. Metals being replaced by a metal. However, we know in acids, like HCl is hydrochloric acid, we know that H plus acts as a cation there, so it can do this too. So acids fall under this realm as well. The metal, the magnesium is going to replace the H, or the H plus in the acid here. Okay? So you're going to end up getting magnesium chloride, and then hydrogen gas is going to be one of the products. So it's usually metal and metal. Now, there's one other particular one I can think of that isn't a metal, and that would be ammonium. Everybody remember NH4 plus? That's also a cation that can switch. That isn't a metal, but it's mostly metal with metal. Here. So this one goes in that 4th row, the example for the cation switch. Everybody good with that? All right. So let's go ahead and look at our lovely friends example. We have Ross and Rachel together, but if anybody knows, here comes Joey. Joey's kind of a player. So now Rachel ends up with Joey, and Ross is all by himself. And that probably happened for like 2 episodes somewhere in there. I don't remember. It was a long time ago. But if you haven't ever watched Friends, it's kind of fun. It's a good show. Anyhow, that's kind of the idea there. All right, let's quiz ourselves. Let's see if we know stuff. How about number 1? Is number 1 a single replacement? No. That is correct. It would be a no, right? What is number 1? What type is number 1? Yes. Number 1 would be synthesis. Very good. How about number 2? Is number 2 a single replacement? No, it's not either. What kind is number 2? Number 2 is a decomp. Very good. How about number 3? Is number 3 a single replacement? Yes. And what's switching here? Is it the cation or the anion? This is where you really know if you know your stuff. Which one's switching? Which one's doing it? The cation or the anion? Good, cation. You see the aluminum's replacing the hydrogen. These are the ones that are switching. So that one's going to be a cation one. How about number 4? No. Number 4 is a no. It's all a synthesis, right? How about number 5? Number 5 is a yes. Good. Is this one cation or anion? Which ones are switching? Cation or anion? The Zn and the PV do switch. I agree. Is that going to be the cation or the anion here? Which ones are usually the cations? The metals, right? The non-metals are usually the anions. So which one is that one? Zinc is definitely a what? Metal. So is lead. So this one would be cation. Very good. Yeah, exactly right. How about number 6? Yes. Number 6 is a yes. Good. So this is going to be iron switching with copper. Also another cation one that we see up here. Okay. Very good. All right, double replacements. All right, thank you. All right. You have a compound plus a compound here. They're going to both switch. All right. The A is going to combine with the D. The C is going to combine with the B. So we end up with AD and BC. Now, when you're writing out formulas, we always put the cation first, then the anion. That's always like the metal, then the non-metal. Okay? So up here, what you're going to see in the particular model diagram, you'll see like the 4 separate, 1, 2, 3, 4 different elements here, or compounds if it's a polyatomic. They break apart and they switch and combine with the other one. So double replacement, also known as double displacement. So it can be a displacement as well. You might see that online if you Google stuff. So AB plus CD gives us AD plus CB. It's kind of like a double switch too, both switch places. All right, so example, sodium nitrate. And nitrate's one of those polyatomics we learned back in Unit 4. And yeah, we have to go back and remember some of Unit 4 now. Does anybody remember what the charge is on nitrate? Close, but not exactly right. What did you say?
I said it's negative something.
It is negative something, yes. Most of the polyatomics are negative. Does anybody remember what the charge is on nitrate? Nope. All right, we're going to definitely have to review our polyatomics for this. But nitrate's -1, okay? So in this particular case, the sodium is going to combine with the chlorine. The potassium is going to combine with the nitrate for them to switch places. So you get sodium chloride and potassium nitrate. Yes, it is, -1. Exactly right. And if you think about it, that follows because we're looking here at sodium. Sodium's in group 1. That means this is a +1. This has to be a -1 because it's 1 to 1 here in the formula. Same thing over here. Potassium's in group 1, so it's a +1. This is a -1, then it's 1 to 1 in the formula. And that's what we're going to do later on when we predict products, is we're going to have to write out the correct formulas. So exactly right there. All right, so here we have Rachel and Ross, of course, and Joey and Charlie. Some of you might not remember Charlie that well if you've watched the show, but she was Ross's paleontologist friend. And if we have double replacement going on, that means Rachel's going to be with Joey and Ross is going to be with Charlie. So it's the double switch. There you go. All right, let's look at some chemical reaction equations and see if we can tell here. Looking at number 1 here, is this double replacement?
I think so.
Yes, good. All right, so, and if you were wondering about this, this is technically water, by the way, but you can write it as HOH. So the magnesium goes with the chlorine, and then the hydrogen goes with the hydroxide to form water, or HOH. Exactly right. How about number 2? No, what is number 2?
Actually, it's not, I don't know. The H2O disappears.
Yes, it combines with the other one. So the 2 things comes together to make the one thing. That is definitely synthesis. Very good. How about number 3?
Yes.
Good. Yes is it. We have sodium, barium. They switch places. The sodium goes with the chlorine. The barium goes with the sulfate. Exactly right. How about number 4? No, this one's a synthesis. Definitely a no. How about number 5?
Yeah.
Yes, good. Number 5 is a yes. This is sulfuric acid. So the H goes with the chlorine, the barium goes with the sulfate. They both switch, sort of like the FOIL thing in math. And last but not least, number 6 up there. What is that? That is decomp. So that's going to put it in the no for double replacement. Definitely not double replacement. We're almost done here, and then we're going to take a short break before we start balancing. All right. Let's talk neutralization, which is a special type of double replacement. So this kind of falls under the subset of double replacement. We have HA and BOH. This is going to go in the generic row, the first row of that section. HA is representing the acid. BOH is representing the base. Remember, acids always have an H in front. Bases are going to have hydroxides on them. From our discussion about acids and bases when we named acids. Now, what's going to happen here is the H is going to combine with the OH. The A is going to combine with the B. So we're going to end up getting water as a product always. Always, always, always. And then we're going to get a salt. Now, NaCl is a salt. We know this. We put it on our food. We call it salt in general, table salt. However, I should point out to you that any ionic compound that has little crystals and forms the lattice and all that, they are all considered in a class of compounds called salts. So any ionic compound they could call a salt. NaCl happens to be one. but in general common name, that's what we call it. Always, always, it's going to be an acid plus a base giving you water and a salt. Those are going to be the criteria for neutralization. So what you want to always be looking for is that H in the front and the OH in the other one. And then you want to look for water as a product. That's the easiest way to do it. Let's look at the example. Hydrochloric acid plus potassium hydroxide. All right, here we go. We get water and potassium chloride. That's the water and the salt. So look for the H, look for the OH, look for the water as a product, and you'll be able to tell the neutralization. Label that separately than just a regular double replacement. Okay, let's do some examples. Number 1, is this neutralization? I'm going to say yes, good. We see H, we see OH, we see water. Very good. How about number 2? Yes, number 2 is a no, very good. We definitely have an acid here, but there is no OH in this one. So this one, number 2, would just be considered regular double replacement. How about number 3? Also, we see the OH, but here there is no acid. No acid here. So this one is just a regular double replacement. How about number 4? We see H, we see OH, we see HOH, which happens to be H2O. So I'm going to go with yes there. Now, this looks crazy. I remember that one. Does anybody else remember that one? What's C2H3O2? It's one of those big polyatomic ions that was on our list. Anybody remember what that one is? The common name for this compound right here happens to be vinegar, by the way. That's acetic acid. So the polyatomic ion here is acetate. Acetate. So we have acetic acid plus lithium hydroxide giving us water and lithium acetate. All right, how about number 5? Is that neutralization? Yes, number 5 is neutralization. Good. We have hydrochloric, we have sodium hydroxide. Definitely fits that one. How about number 6? What say you to number 6? It's a little bit more confusing. This is definitely an acid. This is definitely a base. Now this has 3 hydrogens there. That's phosphoric acid plus barium hydroxide. Our salt is going to be barium phosphate, and then we get the water out of it, so that's a yes. Very good. All right, on to our last type here. Now, once again, you're going to put the generic in row 1 and the other generic in row 3. So skip the example row. All right, combustion, organic plus oxygen. The first one is going to give you carbon dioxide and water. When we say organic, we're talking about like those alkanes and alkenes and alkynes, like CXHY, those hydrocarbons. Now, sometimes they can have other elements in them like oxygen or nitrogen or whatever, but if it has like nitrogen or sulfur or another nonmetal, it's going to have an extra gas product. Organic plus oxygen always gives these 2 products, though, as part of them, carbon dioxide and water. One other thing to note about combustion, oxygen is always a reactant for combustion. Now this one is metallic combustion. It goes in row 3, so put it in row 3, a metal plus oxygen. It's It's going to give you a metal oxide. So you can take metals and burn them in oxygen as well and do metallic combustion. So this goes in row 3. Now what you should also see about the metallic combustion is it also could be labeled as synthesis, because you have two things coming together to make one thing. Okay? So here's some examples. This one goes in row 2. The methane plus oxygen gives you the carbon dioxide plus the water. This is, of course, the lowest of the alkanes, the carbon 1 here. That can go in row 2. Another example, magnesium plus oxygen gives you magnesium oxide. This would be an example for metallic combustion. Take the magnesium, the oxygen, and you get magnesium oxide. All right. Last examples to go through is number 1, a type of combustion. Yes, I see that here. What you really want to look for is, we see oxygen, carbon dioxide, water, check. Some kind of hydrocarbon. How about number 2? Number 2, a combustion.
Yes.
One of your reactants, oxygen. Oxygen has to be a reactant, so is number 2 combustion?
No.
Number 2 is not combustion. Very good. That's a note. How about number 3?
Yes. No. Yes.
Good. Yes for number 3. What type is number 3? Is it organic or metallic?
Organic.
What's this right here? That's iron. So that's a metal. This is definitely going to be metallic combustion. You could also label that as synthesis. Okay, how about number 4? Yes, we see organic, oxygen, carbon dioxide, water. That is going to be a yes. How about number 5? I think this is supposed to be a 3 here, but whatever. Yes, we have organic compound plus oxygen, carbon dioxide, and water. Does anybody remember what this type of organic compound is? Is that OH group? What type of compound that would be with its functional group of OH? Anybody remember? Yes, no? OH groups means it's a what? Alcohol. That would be propanol right there. Rubbing alcohol. How about number 6? Number 6, combustion?
No.
No. Number 6 would be a no. Good. A no. Okay,